Welcome to the Basic Civil Engineering lecture series by Roy M. Thomas.
Hi everybody. Now we will move to the next material used in construction, that is this one. What is this? All of you may be knowing this is nothing but the broken stone, but in civil engineering it is called aggregates. Aggregates. So what are the uses for this? Generally we are using it for many purposes, right? But in civil engineering, where it is used? It is mainly used in concrete. So this is one of the materials in concrete. There are many other materials we will see later. So time being, you understand like this. This is one of the materials in concrete which forms the bulk of the concrete, main quantity of the concrete, main material of the concrete, and which don't have any chemical action with the cement or any chemical action with water. So we will discuss this material, that is aggregate, under the following title. First we will see the types or the classification, then we will see the grading of aggregate, then we will go to the concrete. So first we will see the types, classification of aggregates. Aggregates are classified based on the size. It is classified based on the shape. It is classified based on the weight. So classification is based on its size, based on its shape, based on its weight. First one, based on the size. It is again divided into two. If the size is less than 4.75 millimeters, that is called fine aggregate. Fine aggregate. And if the size is greater than 4.75 millimeters, it is called coarse aggregate. So aggregates are classified based on the size as fine aggregate and coarse aggregate. If the size is less than 4.75, it is called fine aggregate. Now you see this aggregate size is less than 4.75 mm. What is this? This is sand. So example for fine aggregate. Example for fine aggregate is sand, river sand. And if the size is greater than 4.75, obviously the size of this one is greater than 4.75 millimeters. So example for coarse aggregate is broken stone. Broken stone. So this is the first classification based on the size. Fine aggregate less than 4.75. Example is river sand. Greater than 4.75, coarse aggregate, example is broken stone. Now coming to the shape. If you take the smallest particle of this one, that is the smallest one, that is round in shape. So first shape is rounded aggregate. Rounded aggregate. Example is again river sand. Now you see this one. If you want, you can measure what is this angle. If you want, you can measure what is this angle. So that is the next shape, that is angular shape. Second one, angular shape. Angular aggregate based on the shape. Angular aggregate. Example is broken stone. Broken stone. The next shape, I will show another type of aggregate. This one. What is this? This is gravel. Okay. So what is the shape of the gravel? You see, This is, we can say, irregular shape, or even if you want, you can say partly rounded shape. So, next shape is irregular shape, irregular or partly rounded, irregular or partly rounded. Example is gravel. Two more shapes are there, elongated shape and flaky shape. What is meant by elongated shape? Elongated means length is more compared to other two dimension. Say for example, this you see here length is more. What is this one? This material or this aggregate? This is granite. This is a small piece of a granite. So, here granite or marble we can cut according to our requirement, either length as more or thickness as less. All of this material, that is granite as well as marble, both are used for laminating purposes. So, example for elongated and flaky laminating rocks or laminated rocks. If you are so specific, you can write example as granite and marble. For both the shape, example is granite and marble, granite and marble. Flaky means thickness is less, length is more, elongated shape, thickness is less, flaky shape. So, generally for these two, example is quoted as granite and marble. So, this is the classification based on its appearance or based on the shape, rounded shape, angular shape, irregular shape or partly rounded shape, elongated shape and flaky shape. The third classification is based on the weight. As we know, aggregates are mainly used for making concrete. So, this classification is based on the weight of the concrete. There are three types: heavy weight, normal weight and light weight. Heavy weight, normal weight, light weight. As I already told you, aggregates are used for making concrete. So, this classification is based on the weight of the concrete, based on the weight or based on the density of the concrete. If the concrete is having heavy weight, the aggregates used are called heavy weight aggregate. If the concrete is having normal density, the aggregates used are called normal weight aggregate. If the concrete is having light density or light weight, the aggregates that are used are called lightweight aggregate. So, first one, heavy weight aggregate. If the concrete is having high density, say for example 3000 to say 5700 kilogram per m cube. That means, if you take 1 m cube concrete, say 1 meter length, 1 meter width, 1 meter depth, 1 into 1 into 1 m cube concrete, if that concrete gives a weight or a density of say 3000 to 5700, that concrete is called heavy weight concrete and the aggregates used are called heavy weight aggregate. So, example for heavy weight aggregate: steel shorts. So, last discussion we have seen bricks can be used as aggregate, brick pieces. Similarly, small steel iron shorts can be used as aggregates. If that is the case, the concrete will give very high density. So, that is called heavy weight aggregate. And the next one, normal weight. If the density of the concrete is between 2300 to say 2700 kilogram for 1 m cube, that concrete is called normal weight concrete and the aggregates used are called normal weight aggregate. Example for normal weight aggregate: so normal concrete. So, your roof constructed by normal concrete. What are the different types of aggregate used? River sand, broken stone. So, example for normal weight aggregate: river sand, broken stone. And finally, if the density of the concrete is between say 1450 to say 1750 kilogram for 1 m cube, that concrete is called lightweight concrete and the aggregates used are called lightweight aggregate. Example for lightweight aggregate, slate, that is a type of stone. Slate is an example. So, this is the classification based on the weight. Classification is based on the weight of the concrete, heavy weight, normal weight and lightweight. So, classification types of aggregate based on the size, based on the shape and based on the weight. Now, we will move to a very important term, grading of aggregate. So, what is meant by grading of aggregate? As you know, concrete consists of different materials, cement, sand, etc. Assume a sample of concrete. So, I will call this as sample 1. Another concrete, same volume, same size or same volume, sample, say sample 2. For making sample 1 concrete, assume I am using same size of coarse aggregate. What is the size of coarse aggregate? Size is greater than 4.75. It can be 5 mm, 5.5, 7, 6, 8, like that, any size. So, assume I am using say 8 mm coarse aggregate, 8 mm coarse aggregate to make this concrete. Okay. Now, here you see in between the coarse aggregate there are voids or gaps. In concrete, these gaps will be filled by fine aggregate. What is the size of fine aggregate? Size is less than 4.75. It can be 1 mm, 1.5, 1.75, 2, like that. Assume I am using 2 mm coarse fine aggregate to fill up the gap. 2 mm coarse aggregate to fill up the gap. Still voids are there, still gaps are there. In concrete, that gaps will be filled by cement and water. So, all the gaps are filled by cement and water, all the gaps are filled. Now, consider the second sample of concrete where I am using different sizes of coarse aggregate. I am using say 4.75, 76, 78, 79, 4.8, 4.9, 5, 5.2, 5.3, 5.4, like that, different sizes of coarse aggregate to make the second sample of concrete. Still voids are there. To fill up that voids, I am using different sizes of fine aggregate, 1 mm, 2 mm, 1, 2.2, 2.3, 2.4, 2.5, 3, 3.1, 3.5, 3.65, 4, 4.1, 4.2, 4.7, 4.74. Now, still gaps are there, voids are there, that voids will be filled by cement and water in concrete. Now, here you can see two samples of concrete, sample 1 and sample 2. For making sample 1, same size of coarse aggregate, same size of fine aggregate and cement and water is used. Here sample 2, different size of coarse aggregate, different size of fine aggregate, cement and water. All the gaps are filled in sample 2 and sample 1. Now, the question is which sample you may prefer for the construction subjected to two conditions. The first condition is cost of making the concrete should be minimum and the concrete should give maximum strength. So, what is your option? There comes the definition for grading. What is your option? Sample 1 or sample 2? You have to go for, always you have to go for sample 2. Why? In sample 2, different coarse aggregates are used. So, the gaps are minimized. That minimum gaps are again filled by different sizes of fine aggregate. Again gaps are minimized. That minimum gaps are filled by minimum cement and minimum water. Whereas, in the first case, same size of coarse aggregates are used. That means gaps are maximum. To fill up that gaps, again same size of fine aggregates are used. If you are using same size of fine aggregate, gaps will be maximum here. So, gaps are maximum here. That maximum gaps are filled by maximum cement and maximum water. So, if you use maximum cement, cost will be high. If you use maximum water, timing you understand like this, if you pour more and more water to cement or concrete, strength will decrease. So, here maximum cost and less strength, whereas here voids are minimized by using different size of coarse aggregate, different size of fine aggregate, voids are minimized. There to fill up that minimum voids, only minimum cement, not less cement, minimum cement and minimum water is used. Minimum cement means cost is less, minimum water means strength is high. This is called grading of aggregate. So, what is grading of aggregate? To make an economical concrete, different sizes of coarse aggregate and different sizes of fine aggregate should be used, so that the voids can be minimized. By minimizing the voids, only minimum water and minimum cement is required, which further means increased economy, more strength, lower shrinkage. That is called grading of aggregate. Hope it is clear for you. This is important. This term is important. Cement plus fine aggregate, that is river sand, plus coarse aggregate, that is broken stone, plus water. What this mixture is called? Immediately you may say concrete. If this is concrete, what is this mixture? Cement plus fine aggregate, that is river sand, plus coarse aggregate, that is broken stone, plus water, plus steel. Then what this is called? This is called reinforced cement concrete. In short form, R.C.C. reinforced cement concrete. If this is R.C.C, we can simply say this as concrete. This is called plain cement concrete. In short form, it is called P.C.C. P.C.C and R.C.C, plain cement concrete and reinforced cement concrete. What is the purpose of steel in concrete? What is the purpose? Not to give strength. There is a specific purpose. So, usually the beams are constructed or cast with the help of steel. What is the purpose? Now, consider a beam supported over two columns or two walls. Beam constructed by P.C.C. Normal case it is not possible, but assume constructed by P.C.C. P.C.C concrete representation, graphical representation is like this, small triangles and dot, which means concrete. Now consider another beam again supported over two columns or two walls constructed by R.C.C. R.C.C means there should be steel rod. Okay. Now, what may happen if you apply load on it, or if you construct the roof, what may happen with P.C.C or with R.C.C? So, this force is called compressive force. Now, I will explain it with the help of a small stick. Assume or consider this as a beam supported over one column here and another column here. Now, we will see what will happen if you apply compressive force or if you apply load over it or on it. Assume it is supported here and another support here. Now, I am going to apply the force over it. Oh, wow! You see, it is broken. How the failure developed, that is important. When I applied the force or the load at the top, you see the failure developed from the top or bottom. The failure developed from the bottom. You see the failure developed from the bottom. So, when I applied compressive force at the top, failure developed from the bottom due to tensile force. When I applied compressive force here, the beam failed due to tensile force. So, failure, crack developed from the bottom. Same thing will happen here also. When you apply a compressive force at the center of a P.C.C beam, failure will develop from the bottom. This beam will fail, definitely it will collapse. But here you see, if you apply the compressive force, bottom region will be under tension. Here also there will be tension, but there will not be any failure. That crack, that failure will be arrested by the steel rod. That is the purpose of steel in concrete. Why? Because steel is strong in tension, whereas concrete is weak in tension. So this is the basic of all the civil engineering design. Steel is strong in tension, whereas concrete is weak in tension, which means if there is a tensile force, you have to provide steel. Now it is clear what is the purpose of providing steel rod in concrete, not to give strength. Now it is clear. Steel is provided in concrete to arrest the tensile failure or to take care of the tensile force, because steel is strong in tension, concrete is weak in tension, which means if there is only compressive force, we can very well use P.C.C. Can you say in a building where only compressive force is coming, or where concrete is used without steel reinforcement? That is ground floor flooring. Ground floor we can use P.C.C, but when it goes to the first floor there will be tension. So there should be steel rod for the roof. So ground floor we can use very well use P.C.C if there is only compressive force. Hope it is clear. Now, any idea in what proportion cement, sand and aggregates are mixed together to make concrete? If I say 1:2, 2:4, which means 1 part of cement, 2 parts of sand, 4 parts of aggregate. That is the meaning of this mixed proportion. It can be 1 kg, 2 kg or 4 kg. It can be 1 say m cube, 2 m cube, 4 m cube. That is the proportion. So if you make a concrete like this in the ratio cement 1 part, sand 2 parts, aggregate 4 parts, and if you make a cube and if you test it after how many days? 28 days. Why 28 days? Cement or concrete will attain its maximum strength at 28 days. When we discuss cement, I have mentioned this. So if you test this concrete at 28th day, that concrete will give a compressive strength of 15 newtons per mm square. That is the compressive strength. At 28th day. And this concrete is designated as M15 concrete. Designation of the concrete, M suffix 15. M stands for the mix, 15 stands for the compressive strength. Suppose if you want to get some more strength, how to get more strength? By keeping cement in a concrete mixer. If cement is more, strength will be more, naturally strength will be more. But how you can get more strength? By keeping cement same, say cement 1. How to get more strength? Reduce sand, reduce aggregate. Proportionally the cement quantity will be more. Say instead of 2, add 1.5. Instead of say 4, 3. And this concrete will give a compressive strength of 20 newtons per mm square. So what is the designation of that concrete? That is called M20 concrete. Now still if you want to get more strength, say for a multi-storied building, if you want to go for more strength, so how to get more strength? Again reduce the quantity of sand and quantity of aggregate. Instead of 1.5, say put 1. Instead of 3, say put 2. That concrete is designated as M25 concrete. What will be the compressive strength? 25 newtons per mm square. In some cases we need not go up to say 50 newtons per mm square. If there is no weight or no load, you can save some cement. So how to reduce the strength? Increase sand, increase aggregate. Say 1:2, say 3:6. That concrete will give only 10 newtons per mm square compressive strength, and that concrete is called M10 concrete. So this is called the proportioning of materials for making concrete. So, here you see always aggregate quantity is doubles of the sand quantity 3, 6, 2, 4, 1 1/2, 3, 1, 2. For normal concreting works as per the latest Indian standard specification, that means if you want to construct your own house, M20 concrete should be used. So, the mixed proportion should be 1:1 1/2:3. Compressive strength 20 newtons per mm square. To get the target strength, cement should be fresh. Maximum permitted time for storage of cement is only 1 month. If you exceed 1 month, the strength naturally strength will decrease. Sand and aggregate should be according to the specification, that is size. Sand less than 4.75, that too different sizes, not single size. Similarly, aggregate greater than 4.75, different fractions. And all these materials should be free from impurities, dust, organic matters, etc. And next is water. What should be the quality of water? Quality of water should be equal to the quality of drinking water. So, these are the conditions to get the target strength. So, for normal construction, M20 concrete is used. This is also called grades of concrete. Grades of concrete. Don't confuse with the grades of cement, grading of aggregate and grades of concrete. Grades of cement means 33, 43 and 53, that is the compressive strength at 28th day. Grading of aggregate means different sizes of aggregate to produce the economical concrete. Grades of concrete means different proportion of materials, M10, M50, M20, M25. So, to rewind, now we have seen the aggregates. So, what is aggregate? Aggregates are one of the materials in concrete. You see, one of the materials in concrete which forms the bulk of the concrete. You see, the main quantity, larger quantity is always aggregate. So, which forms the bulk of the concrete and do not have any chemical action with the cement or water. Based on the size, it is classified as fine aggregate, coarse aggregate. Examples. Then based on the shape, angular, irregular, elongated, flaky. Based on the weight, heavy weight, normal weight and light weight. Then we have seen P.C.C, R.C.C, plain cement concrete, reinforced cement concrete. What is the purpose of putting steel rod in concrete? To take care of the tensile force or to arrest the tensile failure or tensile crack. Then we have seen the proportioning of materials for making concrete, M10, M50, M20, M25. Thank you.